In today's lesson video, we're going to take a look at volume. Day 7.4, we're talking about volume measurements, okay? And volume is the amount of space taken up in a three-dimensional object, okay? We're talking about the amount of three-dimensional space, or 3D space. And the object, that volume is always measured in cubic units, cubic or cubed units, okay? So as we go through and look at our volume formulas, the first thing we're going to look at is volume of a prism, including cylinders. Prisms and cylinders kind of go together. And the volume formula for prisms and cylinders is volume equals capital B times H. Now, H still means height of the prism, okay? That is the distance from the base shape to the base shape. All right, which brings me to what that capital B stands for. Capital B is the area of the base. Capital B meaning it's a two-dimensional figure. So in the case of a cylinder, the base is this circle, okay, or this circle here. These are both bases. All right, so the volume would be the area of that base, or in this case, volume has an area using pi r squared, because the base is a circle, times the height, which is the distance from one base to another. So this is kind of a more complicated version of the volume of a cylinder, pi r squared times h. But in any other prism, volume is just the area of the base times the height. Area of the base times the height. Area of the base times the height. Just over and over and over again, kind of memorize that. And the only thing that changes from one prism to another prism is the shape of that base. And since the base of this one is a triangle, we would use the area formula 1/2 base times height. This height is not the same as this height. Okay, those are not the same. Okay, this height is the height of the prism. This height in your formula is the distance from one side to the other side at a right angle. That's the height of that triangle. Okay, so like that would be that h. And then this is probably the more simple version of volume that you've probably done before. You guys have probably seen a volume of a prism shape just given as length times width times height. That's the volume of a rectangular prism. Well, here's why we get that. It is length times width times height, because the area of the base, that base is a rectangle. How do you find the area of a rectangle? Length times width. So length times width gives you the area of the rectangle, and then we just stack that. We multiply it by the height of the prism. Okay, so let's try some examples. In this first example, this would be considered a trapezoidal prism. And to find the volume of a trapezoidal prism, we need to know the base area, which is the area of that trapezoid. Okay, the area of the trapezoid can be found using our trapezoid area formula. Okay, remember that that is 1/2 height of the trapezoid times base 1 plus base 2. And so that's what we're going to do to find that one. And then the volume formula is going to take that area of one of those trapezoids times the height of the prism. The height of the prism is the distance from one trapezoid to another. This little 2 up here in the corner is actually the height of the prism. Okay, so let's find the base area first. Okay, base area, the trapezoid has a height of 3.5, so we're going to do 1/2 times 3.5. And the trapezoid has bases of 2 feet and 6 feet. So there's your B1, there's your B2. Okay. Now, when I work all that out and simplify it, I get a total area of one trapezoid. And again, you can pause and check this with your calculator if you want, but the area of that trapezoid should be 14 square feet. I'm going to take that to use in my volume calculation. I'm going to do the area of the trapezoid. Remember, volume is base area times height. So I'm going to do that 14 times the height of the trapezoid, which is the distance from one trapezoid to another. Sorry, Said that wrong. Height of the prism, which is the distance from one trapezoid to another. That's 2. So when we multiply those, we get a total volume of just 28 cubic feet. Okay, let's try another one. This time it's a cylinder. And remember, volume is always just base area times height. And so our base area, since the base of every cylinder is a circle, that area is pi r squared. Okay? And so we're going to do pi times the radius squared. Now the radius is from the center to the point on the circle. They point to this line and call it 2, but that's the full diameter. So the radius equals 1. So pi times 1 squared. So my base area is 1 squared, which is 1, times pi. Well, 1 times pi is just pi. And we know what that would be rounded to the nearest tenth. There's no calculation to do. Pi is about 3.14. So if I round that to the nearest tenth, that's 3.1. So I'm going to take that base area, 3.1, or 3.14, or just call it pi if you want. And we're going to multiply that by the height of the cylinder. The height of the cylinder is from one circle to another. There's your height of the cylinder, and that's just 1. Well, this works out really nice because 3.1 times 1 is still just 3.1, and we are measuring in cubic inches, or inches cubed. All right, now let's continue and look at some more volume formulas. Now this time we're going to look at volumes of pyramids and cones. Now pyramids and cones are grouped together. A cone is like a circular pyramid. We're going to use this volume formula. I'm going to show you what it is, and I'm actually going to transition and show you a different video clip in this video to show you where and why we get this specific volume formula. So 1/3 base area times height. Now, sometimes it's easier to think of that as base area times height, all divided by 3. And again, capital B is still the area of the base shape. Okay, and height is still the height to the point. All right, it's the height of the pyramid from the base up to the point at a right angle. And you can see in my pyramid here, this would be my height. I want you to watch this next clip, and it shows you kind of how we get that formula.
So first of all, I want you to remember this. The volume of a prism is equal to the base area, or area of the base of that prism, times the height. So if I had this prism, you'll see we would call this a pentagonal prism. The volume would be the area of one pentagon times the height of the prism. So here's what I want us to think about. What would the volume of a pyramid be of those same dimensions? Okay, where my pyramid is the same base size and shape and same height as the prism, but it's a pyramid instead of a prism. So we're going to look at that by answering this question. How many times can the pyramid fill the prism of those same dimensions? So we're going to illustrate that with some colored liquid that can best represent our volume. So I want you to take a guess here and write down on your notes how many times you think this amount will fill this amount. All right, and let's see what we get. I'm going to try my best to fill this to the very top without overflowing. Okay, so there's 1. Let's try it again, because we're not quite full yet. Ooh, got it real full that time. There's 2, so it's more than 2. And there's 3, and actually that first one was a little bit less, and so it would actually have filled right up to there. So how many pyramids did it take to fill the prism? 3. And so we should be able to help understand what the volume formula for a pyramid is based on the volume of a prism. The prism was base area times height. It took 3 of these pyramids of the same base area and height of the prism to get that area. So the volume of a pyramid of those dimensions would be 1 of these out of a total 3, or 1/3 the base area times the height of your pyramid. All right, the same kind of thing is going to work out with cones. Okay, but we want to test this out. I'm going to try and put this all back together and show you how it works for cylinders and cones. So let's take a look at cylinders, and remember that the volume of a cylinder is pi r squared, which would be the area of a base, times the height of the cylinder, the distance between those bases. Now, we want to then figure out what the volume of a cone would be with the same circular base and the same height. Okay, you can see those are the same. All right, now for pyramids and cones in this lesson, notice we're just using actual height. I'm not using slant height like surface area did, because I'm not talking about the surface on the outside. I'm talking about how much space is taken up. So again, I'm going back to using the height measurement. All right, so if I have one cone that is the same base area and height as its corresponding cylinder, we again want to ask ourselves this question. How many times can one cone fill the cylinder of the same dimensions? So let's try that. One, and this is going to be a little harder to pour. Two, again, trying to be careful. And let's see if a third one will top it off. Right up to the top. So again, we had 3 cones that filled up one cylinder as long as they have the same dimensions, same base area, same height. So if it took 3 of these to fill this, that means this volume, the amount of liquid or amount of substance that would fit in one of these, has to be 1 out of 3 total that fill this shape. So once again, how many times can we fill it? 3. That means that our volume of a cone formula is 1/3 the volume of the cylinder, pi r squared h. Remember, we're talking about the actual height from the top down to the bottom, or if you're talking about it this way, from the top down to the bottom. All right, the next part of the notes, we'll actually take a look at using those formulas to solve some problems.
All right, so hopefully that makes sense that it would take 3 of these pyramids to fill a prism of the same dimensions, or same thing with cones. 3 of these cones would fill up a cylinder of the same dimensions. So now we've got these formulas, okay? For any pyramid, it's 1/3 the area of the base times the height, or area of the base times the height divided by 3. Same thing for a cone. We're going to do base area, pi r squared, times the height of the cone divided by 3, or 1/3 of that. All right. Now, what you need to pay attention to, if for some reason I do not give you the actual height, all right, remember that when I draw the height to the center of the base, or the center of the circle, and the radius in this case, and the slant height, those form a right triangle. And so we still have a squared plus b squared equals c squared. Well, a and b is the relationship between the height and the radius here. So height squared plus radius squared equals this slant height squared. Okay? And the same thing would work for pyramids. All right? We have right triangles where the bottom side of that triangle, the bottom right leg of the right triangle, is half of the side length. Okay? And then the height and slant height are the other 2 sides. And so you can use Pythagorean theorem there as well. So let's practice some of this. Now in this case, we don't have to use Pythagorean theorem because I do have the height of this cone. The height of the cone is 3. The radius is 1. Everything's given to me very straightforward. So the volume of any cone, again, is 1/3 pi r squared times h, or 1/3 the area of that base circle times h. So that's going to be 1/3 of pi times that radius of 1 squared times my height of 3. And I can put all this into the calculator, but you're going to notice something pretty interesting when you do that. I'm going to simplify everything in terms of pi first. Okay, so I've got my 1/3, or instead of writing it that way, I could write it as pi times 1 squared times 3 all over 3. Makes it a little bit easier to see. This times 3 here and this all over 3 there cancel each other out. Okay, times 3 and divided by 3, or times 3 and times 1/3, think of it that way too, cancels each other out. So I just have 1 squared pi. Well, that's 1 squared is 1 times pi. Well, that's just pi. So like we had in an earlier problem, our answer is just pi, or approximately 3.1 cubic centimeters. Okay, if you're not getting that, if you're getting something closer to 9 point something or 10, then you probably forgot to divide by 1/3. All right, let's move on and do the same thing with a pyramid. Okay, again, volume of any pyramid is 1/3 the area of that base times the height. So I've got to find the area of my base first. Well, the base is a regular hexagon, 6 sides. All right, and since it's a regular polygon, we're using the area formula. Area equals apothem times perimeter divided by 2. Okay, the apothem is this distance from the center to a point on the side like this. So that's my apothem A. And the perimeter is just the sum of all 6 sides. Okay, the perimeter would be 6 sides times 6 meters each side gives us a total 36 for the perimeter. So my base area, B, capital B, is the apothem, 5.2, times my perimeter of 36, all over 2. When I simplify that, when I do that calculation, I get that base area is 930, or sorry, not 900. Look, I missed the decimal. 93.6 for the base area. Okay, so my volume then is 1/3 of that 93.6 times the height of the pyramid. The height of the pyramid is this distance here. That's the height of the pyramid, 11. So when I do that calculation, 936, sorry, I keep reading that wrong, 93.6 times 11 times 1/3, or divided by 3. Okay, instead of doing times 1/3, you can think of it as all divided by 3 like that. That might be easier to calculate. Then we get a total of 343.2 cubic meters. All right, just a few more examples to finish out our notes. Now we're going to look at volumes of spheres. Volumes of spheres have a very specific formula to use, okay? The volume of a sphere is 4/3 pi r cubed to the 3rd power. So there's some calculator things we need to look at. But that's your volume of a sphere, 4/3 pi r cubed. And again, I could go into the calculations based on this, but for right now, just memorize that formula. R is still the radius of the sphere, okay? So to enter 4/3 in your calculator, you could just type in parentheses 4 divided by 3 parentheses. Okay, that's the easiest way to enter that fraction in your calculator. To type in the 3rd power, you're going to use the caret key. Okay, it looks like a rooftop, and then type in a 3. That caret key raises anything to a power. So when you have to do your radius to the 3rd power, you're going to use that process, and I'll kind of show you and demonstrate that too. So this is what your volume of a sphere formula is, 4/3 pi r cubed. So let's try this. This sphere has a radius of 7. So my volume is just 4/3 pi times 7 to the 3rd. So this is the order in which I would type this in the calculator. Okay, so I would type in parentheses 4 divided by 3 parentheses times pi times 7 to the 3rd power. You're going to make it look like that. I'll even do the calculator part with you. Okay, so like I said, parentheses 4 divided by 3 parentheses times pi times 7, and then there's that symbol right there, that caret symbol, to the third power, and it should make it look kind of like that. And we get 1,436, and then we're going to round that to the nearest tenth, so make it 0.8. Again, this would be your final answer. The volume of the sphere is 1,436.8 cubic inches. Okay. For this one, be careful as you enter this. If you look at this, you see that 24 millimeters. Notice they draw the full line all the way through the sphere. So that's actually the diameter. So if that's the diameter, the radius would be half of that. So the radius is 12. So again, we're going back to our formula. 4/3 pi times that radius of 12 to the third. So again, this is what the calculator gives you. Parentheses, 4 divided by 3 parentheses to get your 4/3 times pi times 12, and then the caret symbol to raise it to the third power. Okay. And if you do that, if you type it in the calculator, you can try this one on your own, see if you get this. This is the answer you should get. And because we're doing volume of some kind of bigger numbers, you're going to get bigger answers because you're taking something to the third power. You get 7,238.2 cubic millimeters. Okay. All right, so that's volume of spheres. So there's very specific formulas to use with each problem. Make sure you identify the picture and the shape you're supposed to use, and that'll help you see which formula to use. The only thing we have left to work with are our composite figures. Now, this is a little easier than when we were doing our composite figures with surface area. There's nothing to subtract. There's nothing to take away from this because we're just adding total volumes together. There's no overlapping volumes. They're just stacked on top of each other. So to do the volume of a composite figure, you're simply going to add the individual volumes together. So let's take a look at number 1. We have 2 different prisms we're looking at. The bottom prism is very simple. The bottom prism is just a rectangular prism. Volume of that one, so our first volume, or volume number 1, is length times width times height. Very simple. That's shape 1 on the bottom. Shape 2 on the top, volume number 2, is the area of our base, okay, our base area, times the height. Well, that gets a little tricky. The base area is a trapezoid. So we do 1/2 height of the trapezoid times base 1 plus base 2 of the trapezoid. So to find that, we need the bases of the trapezoid, which are the parallel sides. I've got those. I've got 17 and 6. Okay. And then my height of the trapezoid. Now the height of the trapezoid is from here, I'll mark it over here on the side, just to down here. So I've got to figure out this length, which is part of the 22, because that would be my height of my trapezoid. Well, I'm not just going to guess at that. I'm going to look at the information given. This little vertical side back here is 8. In fact, the height of that bottom rectangular prism is 8. So all of these little segments are 8. That means I'm going to take away 8 from the 22 to get the height of my trapezoid. And 22 minus 8 is 14. So the height of the trapezoid is 14. So now I can calculate the area of that base. When we do 17 times 6, 17 plus 6, that's 23. And then do 23 times 14 and divide by 2, we get a total area of that base, 161. Okay, that's the base area. Now, to find the volume here, we're going to take that base area. So volume number 2 here, that top portion, I actually kind of went out of order, but we're finding that top portion first because it's the most challenging. Volume number 2, we're going to take that base area, 161, times the height of the trapezoidal prism. That's the distance between the trapezoids. So from one trapezoid to the other is 13. Then when I do 13 times 161, I get 2,093. So that's that first, or that volume of that portion. But we have to add in the first volume that we looked at from the bottom part, and that's just length times width times height. 17 times 13 times the height of 8. Okay, when I do those and add those up, I get a total of 1,768. So I'm going to add those two together. When I add these two together, I get a total combined volume of 3,861 cubic centimeters. Okay. All right, we are actually going to skip this next example. We would do the volume of the cone plus the volume of the cylinder. We're going to skip that one and go to just one final example. Okay, one final example here. We're just going to do number 3. That means we're also going to not do number 4. This is very similar to what we skipped though. This would be the volume of a cone plus the volume of this rectangular prism. The volume of the rectangular prism is a little easier to find. Okay, so volume number 1 would be this bottom portion. That's just length times width times height. I'll go ahead and do that one first this time. Length we can call 12. Width we would call 9. Height we would call 4. So we're going to multiply those dimensions and get that total. When I do that, that gives me a total of 432 for the bottom portion. Okay, so we're going to have 432. We're going to add in the top portion for that cone. All right, the volume of a cone is pi r squared times height divided by 3. Remember, we take for cones and pyramids, we use that 1/3, or we divide by 3. So the radius of the cone is very easy to see. The radius is 3. So pi times 3 squared. The height of the cone is not so easy to see because it's not actually given to me, but we can calculate that using the Pythagorean theorem. Okay, we're going to use this right triangle where one leg of the right triangle is the radius 3. The other leg is the h that I'm looking for, and the hypotenuse here is 7.6, the slant height. Okay, so we're going to do Pythagorean theorem. I'll kind of come up here. We're going to do 3 squared plus h squared equals 7.6 squared. Okay, so we're going to do that calculation real quick. When we do that, we get a height equal to 6.98. Okay, that's what your height should be. Okay, 6.98 for the height of that cone right there. So 6.98, and that's all over 3. So when I simplify all this, when I do that calculation, you can take some time, put it in your calculator. I would do exponents first, 3 squared, then times pi, then times 6.98, and then lastly divide by 3. The volume of that cone ends up being about 65.78. So that's what I'm going to add in down here so that I get a total volume of 497.8 about cubic feet. Okay. And that kind of concludes this. We didn't finish these out. You are welcome to try these on your own and send me a message if you want to check those answers. Otherwise, this finishes our lesson on volume.